Hi there. During this session I'm going to go over the non-mathematical basics of how we go about generating electricity today. I'm going to begin with explaining how magnets can be used to induce the flow of current, and then later on I'm going to describe how this is applied with the basic setup of a power station. Okay. So, starting with those thoughts, I'll introduce you to a situation. What happens if you move a magnet into a coil of wire? You may ask. Someone did, and they realized that if I move a magnet into a coil of wire, current is produced. So that was an interesting discovery. Some people thought about it in a little bit more detail, and they noticed that the current is only induced when the magnet is moving, so it has to be moving for anything to happen. What happens when the magnet is in the coil of wire? Well, as we can see here, if we place the magnet inside the coil of wire, nothing really happens. Okay, it has to be moving for something to happen. Okay, so only when a magnet is moving is current induced. So this is great. So it means we can produce electricity by moving a magnet into a coil of wire. This was a big discovery. So people went, okay, then this is kind of useful. This is how we can produce electricity on a regular basis, beyond the harnessing of electricity from lightning, as had been done at an earlier stage. Now, they did a little bit more work on this and thinking about what is known as electromagnetic induction, and a few things were noticed. If you go in, the electric current goes in one direction, but as I move it out again, the electric current moves in the opposite direction. So what we're seeing here is a little bit more thinking. It means that the direction of the magnet's motion, comparison to the coils of wire, also has an impact. Now, that means that if I repeatedly moved a magnet in and out of a coil of wire, I'd produce a specific type of current, and this is a current which is known as alternating current. Alternating current means it's alternating direction. As the magnet goes in one direction, the electric current flows. As the magnet comes out again, the electricity current flows in the opposite direction. In, out, backwards and forwards. Now, this first discovery was soon built upon and developed. And first of all, we developed our first alternating current generator. Now what we have here is they decided that moving magnets was okay, but it's actually much easier to move a coil of wire. So what we have in this situation is a coil of wire moving around, rotating, and in between two magnetic poles, so it's in a magnetic field. What we have here is that as the magnetic field or the wire moves in one direction, it moves up on one side and down on the other side, it causes the induction of electric current. So it causes a flow of electric current, and this can be tapped into. So if we can get a coil of wire to rotate around, we can produce electricity, which is an alternating current at its basic form. People thought, okay, how can we make this better? How can we make more electricity? Well, there's 4 ways we can improve this system. Number 1 way to increase this is increase the speed of the movement. So the faster I'm moving around the coil of wire, the more electricity is produced. I can increase the magnetic field strength. I could increase the number of turns on the coil, so I could have more than one turn on the wire. I could several different coils, or several to lots and lots. I could also increase the area of the coil. So these are 4 basic ways which I can increase the amount of current which is produced. Now, this basic idea was tapped into for the production of electricity today. So let's bring it onto a bigger scale. Power stations. A power station is used to produce large volumes of electric current. And how it does this is through this simple system. Now let me introduce you to the parts. I'll talk about how they work later on. We have a boiler system, and this is where coal, gas, oil or nuclear power are used to heat up and boil some water. I've got a turbine which is caused to rotate around. I've got a generator. This is the essence of magnets moving with coils of wire to create electricity. And then we have a transformer. A transformer allows the change of voltage so it can be more effectively transferred around the country. And finally I have a cooling tower where the hot steam is then cooled back down to cold water for this cycle to start over again. Now obviously this is a constant cycle and a repeated cycle, so therefore, as we know about earlier energy degradation, it means that it's not going to be perfectly efficient. There's always going to be some wasted energy. So let's talk about these sections in more detail. Inside the boiler, this is where the fuel is burnt to boil water. Water is converted into hot steam. The hot steam from the boiler is then used to expand out and cause the rotation of a turbine. This turbine in turn causes the rotation of, acting a lot like a dynamo, the normally causes the rotation of a magnet or the movement of a magnet in a coil or a coil of wire moving a magnetic field, one or the other. Either way it causes the generation of electricity. That electricity goes out through the transformer into a national grid around the country, and then the water is cooled back down, or the steam is cooled back down into water, and the process repeats again. So that's the idea of generating electricity. That's the basic ideas of how a power station works, and the idea, or the solid idea at the beginning, about how electricity is induced using the motion of a magnet and a coil of wire. That tells us how energy is generated today.